if you want to perform the division between two complex numbers, what you're going to have to do is multiply the numerator and denominator of the fraction that is created by the division by the complex conjugate of the denominator. Now, two complex numbers are considered complex conjugates if they have the same real part but opposite imaginary parts. So, for example, 5 plus 6i and 5 minus 6i are complex conjugates. Now, be careful. Some students, if they see the real part as negative, they'll try to make it positive when they make the complex conjugate, but the only sign that changes is the one on the imaginary part, the sign right in the middle. Okay, so for example, if I wanted to perform this division, what I'm going to have to do is multiply the numerator and denominator by the complex conjugate of the denominator. Well, since the denominator is 1 plus I, the complex conjugate would be 1 minus I. So I need to multiply the top and the bottom by 1 minus I. Now, a thing to remember that will save you a little bit of time is that when you multiply a number by its complex conjugate, then the following will always be true. It's the real part squared plus the imaginary part squared, and it's always a plus in the middle. Okay, and you don't have to worry about the sign, like one being minus and one being plus here, because if you were to square a negative number or square a positive number, you're always going to get a plus. Okay, so the reason we're doing this is if we multiply a number by its complex conjugate, what we're going to end up is having this form. And notice there are no i's in this. Okay, so what this essentially does is removes the imaginary part from the number and makes it only a real number. So it works similarly to rationalizing a denominator. I guess you could say we're realizing the denominator, and that's not really a word, but it's the way I like to think of it. So what I'm going to do is multiply the top and the bottom by 1 minus I. So I'm going to kind of do this down here. I'm going to do the denominator first. So I'm doing 1 plus I times 1 minus I. Well, according to this equation here, I need to square the real part, which is 1. So I need to do 1 squared, and then let me make that look more like an exponent. 1 squared plus the imaginary part is 1 on each of these, so it'll be plus 1 squared, so it's just 2. Okay, so I know the denominator of this is 2. So now I just need to figure out the numerator. Now the numerator is going to be a little more complicated because I will actually need to FOIL, or I can use the box method if I wanted to for the multiplication. I'm just going to use FOIL for all of these though. So I would do first, which is 2, times outside, which is minus 2i, times inside, which is, let me do that up here, which is minus I, and then last, which is positive I squared. Okay, now remember, I squared always equals negative 1, so this is 2 minus 2i minus I minus 1. So remember that when you FOIL FOIL the product of two complex numbers, the two outside terms will be real and the two on the inside will be imaginary. So if I combine my two real parts, I'm going to get 1, and if I combine my two imaginary parts, I'm going to get minus 3i. Okay, so the numerator of this is 1 minus 3i. Now you can leave it in this form as a fraction form, that's okay, but some people prefer to write it with two very specific pieces, a real part and a imaginary part, in which case what you do is you divide the real part by 2, because that's the denominator, and then you divide the imaginary part by 2. So either of those are okay forms. It's okay to have your complex number written as a fraction as long as the denominator is real. Okay, so here I need to multiply the top and the bottom by the complex conjugate of this. So it's the same thing as this, except for there being a plus in the middle, there will be a minus. Okay, now remember, the whole reason we're doing this is so the denominator will only have a real number in the denominator. So when I multiply two complex conjugates, essentially the imaginary part goes away and it ends up being the real part squared plus the imaginary part squared. So it's 1 plus 36, or 37. So my denominator is 37. Okay, now let's do the numerator. I need to do 1 minus 2i times 1 minus 6i. Now you can't just jump to this formula that we were able to with the denominator that only works when you're multiplying complex conjugates. Okay, so with this one we're going to have to FOIL. So first is 3. Outside is minus 18i. Inside is minus 2i. And last is plus 12i squared. Now remember, when you FOIL, two outside terms should be real. Well, this one has an I squared on it. That I squared becomes negative 1, thus making that term real. Minus 18i minus 2i minus 12. And now I just combine my terms. I combine my real parts and my imaginary parts. So this is minus 9 minus 20, or negative 9 minus 20i. Okay, so that's my numerator. And if you want, you can write it as negative 9 over 37 minus 20 over 37i. Okay. Now the last one, be careful with this. Like I said before, a lot of students, they'll see a negative on the real part in the denominator, and they'll want to make it positive when they multiply by the complex conjugate. But the complex conjugate has the same real part. The only thing that's opposite is the imaginary part. So this needs to stay negative in the complex conjugate. Okay, so the denominator is going to be negative 2 minus 3i times negative 2 plus 3i. So it's, because we're multiplying complex conjugates, it's the real part plus the imaginary part. I'm sorry, the real part squared plus the imaginary part squared. So that's 4 plus 9, or 13. So the denominator is going to be 13 here. Okay, and now I just need to do the numerator. Negative 1 plus 2i times negative 2 plus 3i. Okay, so first is positive 2. Outside is negative 3i. Inside is negative 4i. And last is plus 6i squared. Okay, well, that's 2 minus 3i minus 4i. I'm leaving the first 3 parts alone. I want to change this to a real number by realizing that I squared is negative 1, so this becomes negative 6. So that's negative 4 minus 7i. So my numerator is negative 4 minus 7i. And once again, if you want, you can write it as, let me put the negative outside, negative 4 over 13 minus 7 over 13i. My personal preference is actually to write it like this, just so I could more explicitly see what the real part and the imaginary part is, but it really doesn't matter. This is a slightly more concise notation, so you can leave it like this if you want.